In the onion architecture, how do you make business decisions that rely on information from actions? I get this question a lot, especially when I bring up onion architecture in one of these episodes. And so in this episode, I am going to answer it for everyone. My name is Eric Normand, and I help people thrive with functional programming. So the onion architecture is a way of structuring your application with actions on the outside. These are called the interaction layer, because if you're interacting with the world, you really you're in actions, right? You're receiving requests from the outside, you're making API requests yourself, you're reading from the database, or you're doing a lot of I/O, having effects on the world, you're sending emails, you're making lights blink, whatever your software does. That's all in the interaction layer. And then inside, you have a nice, pure set of layers that are all about calculations. I like to divide them up in a certain way. I like to put business rules as my first layer inside, and then inside of that, a domain layer. Okay, but both of those, it doesn't matter how you divide it up, especially for this discussion. But they're calculations, right? They're pure. They are not based on stuff from the outside. They have no effect on the outside. They're like a little brain that you can give it questions and it will answer the questions, right? It's making decisions, basically. So you got these calculations making decisions, business decisions, even simple domain decisions. And the actions are doing stuff like fetching stuff from the database, sending data to an API. So here's the question that I get a lot. So if you've got the onion architecture, how do you make decisions, which should be calculations, like how many times to retry an API? If it fails the first time, do you retry? That's a decision your software has to make. Or how do you have a calculation that decides that it needs to have more information from the database? Right? It says, okay, I've done a bunch of stuff and now I know I need this more information. It can't get it itself. So how does that information get up to the higher layer so that the higher layer can get it and then give it back to it? And it's weird, right? It starts to sound like a really difficult problem. And like I said, I've gotten this question several times in different forms, but I think it's a thing that I've caused, a confusion that I've caused in how I've explained it, because I'm using language to try to talk about them as separate layers, and people aren't really used to thinking in layers. Okay, so I'm going to try to pick it apart and put it back together with a new explanation. Okay, so when I talk about layers, I'm talking about functions in your language. They're either calculations or actions, right? Functions calling other functions. So function A calls function B. There is a relationship there. And if you draw all of the relationships between functions and what functions those functions call, and then what functions those function calls, and you make sure all of the arrows are pointing down, okay, so you have the stuff that nothing calls up at the top. That would be like your main, right? And then you have the stuff that calls, but nothing else calls. And you can just arrange them all. At some point, you could draw a line and say, everything below this line is calculations, right? Because a calculation cannot call an action. If a calculation called an action, it's not a calculation. So by definition, calculations cannot call anything above that line. Okay, so you could draw a line and say this stuff down here is all calculations. And so the stuff above is all actions. Okay. All right. So that's what I mean by the layers. Okay. It's all just function calls. It's not like some kind of protocol for communicating and getting information. You like, here's a decision I need you to make. So you give me the answer, and then I ask you what I do with that answer. And it's not that. It's just function calls. So let's look at the two examples I gave, these two questions that were asked. So if you have to do a retry, right? You make an API call and it fails. It times out. You don't know what happened. So I'm going to retry it. How do you decide whether to retry it? Let's say your rule in your system is retry it 3 times or retry 2 times. So you try it once and then you have 2 more times to retry it. That's really just a less than, right? You keep track of how many times you called it, and then you see if it's less than 3. And if it's less than 3, then you keep trying, right? And then you decrement or whatever, you increment. And that less than is a calculation, okay? It is not named, and it's probably in line right in your action. But that is a calculation. It is a decision being made. You could, if you wanted to, say, well, actually this less than sign, this less than operation, less than 3, is a business rule. I probably wouldn't call it a business rule. It's more like an architectural rule, a system integrity rule, something like that. But you could say, I want to name this function will decide based on how many times I've already tried the API whether I should try again. Just a simple Boolean, right? So it's basically just the body of the function is just less than 3 or whatever number you choose. And so you could say that's a business rule. Put it in there. Okay? And so the action is just calling this like function called retry ? Or should retry, right? This is just the name of the function. So you notice it's just the action calling a calculation. That's it. That's all it is. Okay? And the action is in the interaction layer, and the calculation is in the business layer. All right, so what if you're doing something and you're doing this big calculation. You've managed to turn it into like a nice data pipeline, and at some point in the pipeline something says, whoa, I need more data from the database. I need this record, or I need this whole set of records from the database to continue working. What do you do? And this is another, I think, again, when I read the question, it sounds like the same thing where people are thinking like, okay, so this interaction layer is telling the business layer to like do all this work, and then somehow the business layer needs to communicate back up to the interaction layer, and it's gonna like go fetch something, and so there's like this back and forth communication. And I don't know what people are thinking, but it sounds a lot like maybe an object-oriented mindset, where you've got these two peers that are communicating. It's like server to peer-to-peer communication with this protocol of like, you tell me what data you've got, and I'll start calculating. And then when I need more, I'll tell you that I need more, and then you'll fetch it for me. And then, then I'll keep going, and then I'll tell you I need more. And so that is not what I'm trying to get at. Okay. When I have taken the code that people have given me as like an example of like, this is really hard to do in the onion architecture. Basically, all I do is I move stuff from, they've got like this big action. It's like 20, 30 lines. And I just move things. I say, oh, that could be a calculation. That's kind of like a business rule, and this is kind of a business rule. And I just move it into calculations. And then the action just gets shorter because now it's just calling these named functions instead of all this inline code. But a lot of it is moving into other actions, by the way. But it's just like threading it through. So, okay, we're going to fetch this thing from the database and then pass that to this calculation. It's going to give us an answer. And then we take another thing from the database and we pass it to the next function with what we already had. And then we make, that's going to do some other calculation. And it just looks like regular code. It just looks like normal code. And so I feel like by naming the thing like onion architecture, I've somehow confused people that they think it has to be much more sophisticated, complicated than it has to be. And so if you are in a, this is just the way I see it. A calculation can only make decisions based on what it knows, what it has been passed through the arguments, right? So it can't say, oh, I need more data. All right. So whatever has to decide this thing needs more data is not a calculation. It's an action in the top, in an upper layer. That doesn't mean so then what comes out is that, okay, we're doing this because of efficiency, because we might not need to fetch that huge data set from the database, and we won't know until we're halfway through the calculation whether we're going to need it or not. Okay, that's cool. That's a different problem, right? So now we're talking about, are we doing a lazy thing, or does this calculation really have a natural point, a break point, where it's really, say, two calculations that can be called separately, and the result from the first thing can be threaded into the second part, right? Is that what's going on? Because the idea that this calculation gets to a point and says, okay, I need more data, the laziness might solve it, right? Like we've talked about that before in previous episodes. We constructed a delay, right? And the delay, it's not the I think it's a suitable thing because the calculation is still pure, even though now by like triggering this delay to be realized, it is fetching data, right? That logic was kind of injected in. It was passed in from the outside. And in fact, I've seen onion architecture implementations that get past a function, and then that function just returns the data. And so you could pass it in a function with dummy data that just gets returned, or you could pass it a function that will fetch the data from the database, right? Does that turn that calculation into an action because it is now fetching from the database, even though it doesn't know? That is a very philosophical question that you're going to have to draw the line somewhere where you feel comfortable with. I would be very comfortable with that kind of thing. But, that's up to you. Okay, so I don't know if I've really done my goal, achieved my goal of deconstructing this and really framing it back in terms of function calls. The onion architecture is just, it's maybe more of just a way to look at it, that you don't have to have everything in a big set of actions, that you can push business rules down into calculations and down the layers. Because remember, if all of our dependencies, all of our function call lines are pointing down, that means calculations they can't call up, right? Because they're below the actions. So that's what I mean by pushing it down. We're taking these business rules, making sure that they're implemented as pure functions, as calculations, and they go into a separate layer that then gets called by the interaction layer. Okay, so that interaction layer is just stuff like, okay, I got a web request. That's an action, right? That depends on when. It's a timely thing. You also can't decide when you get it, right? It just comes. So I got a web request, and now I have to decide what this web request is. So I'm going to route it. So the route, that's probably a calculation. So it's going to take the path and it's going to tell me how this request should be handled. And then I take that information, I know how it should be handled, still in the interaction layer, and I say, okay, so that means I have to call this handler. This handler needs XYZ to be called. It needs a little bit more data, like it needs the user information, like the session, that kind of stuff. And it just adds that in, and then the handler gets called. Handler is probably still part of the interaction layer. It still might fetch stuff from the database. Okay, so this thing is going to fetch stuff from the database, make a big decision or several small decisions from the business rules, package it up in as a response, and then send it back out. Right? So it's all just function calls. Right? The handler is just calling calculations and then coming back. So I look at it like you don't need to do anything special, except just make sure that at some point you do have all calculations going down, right? That you don't have a thing where like this business rule that is like deep down in the call graph is going to like fetch out to the database somewhere, right? That's all it is. It's like, oh, that should actually be up at the top, and make sure the stuff is pure. That's all it is. All right, I hope this hasn't been too mystifying. I fear it has been. So if it has, get in touch with me. I want to talk about this in a way that's more understandable. So like if you have a better way to explain it, if I'm confusing you more, send me examples of things that you don't understand how you could turn into an onion architecture. You can get in touch with me by going to lispcast.com/podcast. There you're going to find links to social media like email, Twitter, stuff like that. Whatever you think is best for communicating with me, based on the length. Probably if you got some code, it's best to go by email, not Twitter. But you decide. You'll also find links to subscribe to this podcast. You'll see all the old episodes with audio, video, and text transcripts. So if you need to go back and binge listen, binge watch, or binge read, it's there. I was looking at it the other day. I have 139 episodes, so this is 140. That's quite a number. So this has been my thought on functional programming. My name is Eric Normand. Thank you for listening, and rock on.